ನಮಸ್ಕಾರ ಸ್ನೇಹಿತರೆ, ಇದು VVSM Academy, a School of Arts and Science. You are seeing a beautiful picture of the ship belongs to Geological Survey of India, the Ministry of Mines, Government of India. The Veerabhadraya Demaya was a retired scientist from Marine Wing Operation West Coast, Mangalore, when he was serving in the department. Yes, friends, starch, cellulose, glycogen are the carbohydrates what we are discussing in the last class. Source, cellulose is the plant origin, beta glucose, 1,4 bonds, branches are no branches in cellulose here. Starch, amylose, amylopectin, and glycogen are the important things, and the diagrams are respective you can see and practice all this information. Glucose units, glycosidic linkage bond. Yes, my dear friends, this is alpha D glucose and this is beta D glucose. Here you can see the glycosidic linkage bond. Cellulose, polysaccharides, carbohydrates in biochemistry. Come friends, let us have a brief discussion and the introductory class to the cellulose is concerned. Discovery cellulose C6H10O5 enzymes. Let us discuss about the history of science today. Cellulose, an organic compound, the most abundant biopolymer on earth. It is a complex carbohydrate with a linear chain of tens to hundreds to several thousand beta D glucose units. It is the principal structural component of plant and algal cell walls. While animals do not produce them, many microorganisms like bacteria also make biofilms. Humans cannot digest cellulose as they lack the enzymes that can break down the beta acetal linkages of cellulose. NSLM Payan discovered cellulose from plant matter in 1838 and determined its chemical formula. It was first used to produce the first successful thermoplastic polymer. Cotton is the purest natural form of cellulose, consisting of over 90% cellulose. 1920, Hermann Staudinger discovered the chemical structure of this macromolecule. Cellulose plays a vital role in providing structure and strength to plants. It also finds great importance in the industry. Well, friends, let us have a brief look on French scientist's discovery. This is the École Polytechnique University in France on those days. This is Mr. Payan, was the scientist. He was born in Paris. He began studying science with his father and later studied chemistry at the École Polytechnique University under the chemist Louis Nicolas. This is the scientist. Vauquelin, French pharmacist and chemist, discoverer of chromium and beryllium. The person is responsible for the discovery of the element chromium and beryllium. Michael Eugene Chevreul, revolutionized the soap and candle manufacturing and led to his isolation of heptadecanoic, margaric, stearic, and oleic fatty acids. First to formally characterize the nature of organic compounds, considered the founder of modern organic chemistry. This scientist. Friends, chemistry is a wonderful subject, what we are discussing today. Well, friends, structure of cellulose. BVSM Academy, a school of arts and science, established its supremacy by showing the important information the students of biochemistry. Leaf. This is from the plant origin, plant cell. This cell wall, cellulose microfibril, and this fibril gives the numbers, thousands, tens, thousands of glucose molecules. Chain of glucose molecules, my dear friends. Maybe alpha glucose. Structural properties of cellulose. Friends, cellulose is an example of a linear polysaccharide composed of a repeating glucose monomers linked by beta 1,4 glycosidic bonds, unlike starch, which is made up of alpha 1,4 glycosidic bonds. The polymerization of glucose units form long chains which combine to create a cellulose microfibrils, a critical structural component in plant cell walls. The hydroxyl groups OH on the glucose molecules form hydrogen bonds with oxygen atoms. The linear structure allows cellulose molecules to form strong hydrogen bonds with neighboring molecules, creating a highly stable network. Each glucose molecule is flipped 180 degrees during joining compared to its adjacent glucose molecule interchain. This alternating orientation of glucose units results in a straight linear chain. Pure cellulose is odorless and flavorless. Due to numerous hydroxyl groups, cellulose is cellulose is a hydrophilic but insoluble in water. Enzymatic hydrolysis of cellulose forms glucose. Cellulose has both crystalline and amorphous regions in its microfibrils. The highly ordered crystalline parts provide strength and resistance to deformation, while the amorphous regions offer flexibility and allow the enzymatic degradation. This is the cellulose fibrils in the cell wall and is further expanded by showing in the microscopic structure of cellulose fibril and the number of glucose molecules, n number of glucose molecules with a hydrogen bond. This is the cellulose microfibril. You see, this is 200 nanometer in the microscopic structure. This is the cell wall. The cell wall consists of so many internal structures, microscopic internal structures. My dear friends, lignocellulosic substrates are appearing in the microscopic structure. Lignin, hemicellulose, and cellulose. In the plant cells, especially lignocellulosic substrates. Starch, cellulose, pectins, gums, which are the important plant origin polysaccharides. Thank you. Like, subscribe and share. This is Veerabhadraya Demaya from VVSM Academy, Kalyananagar, Bangalore. Thank you.